Okay, this was the second problem that I was asked in class to do. So I'll read it off. At this instance shown, rod AB has an angular velocity of 3 and an angular acceleration of 5. Determine the angular velocity and angular acceleration of CD at this instant. Okay, so what I need to do is to determine whether or not I need a free body diagram. To do that, I have to count the degree of freedom. So what I do is I know that rod AB is moving, so I count 1 degree of freedom. If you hold rod AB still, it seems obvious to me that nothing else can move, and so there's only 1 degree of freedom. So there's 1 degree of freedom. What this means is if you give me 1 velocity, 1 acceleration, I can find all other velocities, all other accelerations. By the way, if you give me 1 angle, I can find all distances. If you give me 1 distance, I can find all angles, etc. So, essentially it's 1 of no derivatives, 1 thing that has 1 derivative, and 1 thing that has 2 derivatives, and you can find all the other things that you want. So it's doable. I do not need a free body diagram. Okay, so the next thing to do is to identify the special points. In this particular case, the special points are A, because it's tied to the ground and I know something about it. C, because it's touching the link and it's also touching the collar and it's also sliding along the bar AB. And then D is also a special point because it's touching the ground. Therefore, I know what it's doing. Okay, so those are the points. I'm going to write an equation between D and C. If you notice that link, that's the vertical link, has 2 special points on it. 2 minus 1 is 1, so I'm going to write 1 equation. So I'm going to do the velocities first. So this is going to be velocity of C. It makes no difference which one you start with. I like to put my known numbers over here on the right hand side, but it doesn't matter. Velocity of C equals the velocity of D plus omega. This should be the omega of the body that they're on together. If you notice, I don't know what the angular velocity is, so I'm going to call it omega dc, or CD, makes really no difference, just whatever. And I think it's going to go counterclockwise. I have no idea what it's going to do, so I'm going to say it's a positive omega dck. So I think it's going counterclockwise. Crossed with, and the R has to always go from this point that you have on the right hand side to the other point. So it's going to go from D to C. So RDC plus VREL. Right? There's always the plus VREL, plus VREL. Okay, now let's plug numbers in here. So the velocity of C equals, what's the velocity of D? Well, D is in permanent contact with the ground, so it has the same velocity as the ground, which is 0. Let's see, let's put a number in here. This is omega dc, K, cross. Okay, let's plug in for the R. R goes from D to C, so it's a distance of 0.5, and it's straight up. So I'm going to say I is to, as usual, I is to the right, J is up, K is out. The only problem that you have is you got to make IJK right-handed. So if you take your fingers of your right hand, put them in the direction of I, curl them towards J, you'll get K coming out. That's the only problem or issue that you would have, is to make sure that K is always right-handed. But anyway, so it'll be 0.5 and it's straight up, which is what I'm calling J. And then the VREL is 0. Why? Because C and D are on a body together. They're stuck on that body together, so there's no relative velocity. Right? So now I have 2 points on the link AB. Those points are A and C. So there's 2 points. 2 minus 1 is 1. I'm going to write 1 equation between those 2 points. So here we go. Velocity of C equals the velocity of A plus omega. What omega? It's going to be the omega of the body they share. Well, the body they're sharing is AB. So the omega of AB is given to me to be 3 counterclockwise. So that's going to be 3K cross. This is going to be R from A to C. Right? Let's see, what am I missing? Oh yeah, plus the VREL term. VREL. And if you want to, just make sure that you know it's between the C and the A. Okay, so there we go. Okay, let's plug numbers in. Velocity of C, don't know it. Velocity of A, oh, he's in permanent contact with the ground, so he is got the same velocity as the ground, 0. Okay, let's do the cross, well, let's plug in for the R. Plus 3K cross. Okay, this one's a little bit trickier, but it's not a big deal. So what I'm looking for is I'm looking for this distance right here, and that would be a distance D, we'll call it. I'm not sure how far it is, so we'll call it a distance D. And it'll be in the sine of 60 degrees to the right. And then it's going to go down, right here, it's going to go down this distance, which is the cosine. Down is negative, and it'll be cosine of 60, J. So there's my R. All right? The VREL, okay, do I have one? Yes, because C is not fixed to the body AB. It's sliding along. Okay, so how do you find it? Well, you pretend like you're standing here, and you're riding along on the rod. You look over there at A, you say, oh, he's stuck at the end of the rod. He's not doing anything. But what does C look like he's doing? Well, what he looks like he's doing is he's either sliding out or coming back in, one or the other. I don't know which one. So I think he's doing this. I'm going to call it little v. Right? I don't know how fast he's going, but he sure looks like he's going down AB. So I'm going to write that down. Okay, so I say, all right, well then, what does he look like? Oh, I think he's going out the rod, V. Out the rod is going to be sine of 60 in the I, and he's going to be down, right, because if he's stuck on the rod, he's going to the right and a little bit down, cosine 60J. So that's what he looks like he's doing. And I don't know that he's going out. He might be coming in. If that's the case, then I'm going to solve for little v. Little v is positive, meaning, oh, that he's doing what I thought. Negative means he's going the other way. Okay, so no big deal. All right, so let's count how many unknowns. All right, so what I have is velocity of C. Well, I've got an I and a J here. All right, so there's 2 unknowns on the C. Okay, actually I should label it here, right? There's 2 unknowns in the C. Do you know omega DC? No, I don't know that guy, so I'm going to circle him. Don't know that guy. Okay, that's an equation here. How many do you have? Oh, you have two equations. You have I equal I and J equal J. Okay. For the next guy, I've already counted the velocity of C. What else do I have? Oh, I don't have little v, and I don't know d. Okay. So how many unknowns do you have here? Another 2. How many equations? 2. So you have a total of 4 equations, and you have a total of 4 unknowns. Okay. Now, how in the world are you going to find the distance d? Oh, actually, d, yeah, I just noticed it right here. At this moment, d happens to be equal to 0.75. Okay, so d is known. I've got v and I've got vc, 3 unknowns, and it looks like I've got 4 equations, 2 from the first vector and 2 from the second vector. Okay, let's go ahead and grind it all the way through. And what I would do is I punch this into Mathematica. I'll post something about that a little bit later, but let's just grind it out by hand and see how we solve this thing. Okay, so here we go. The top equation, velocity of c. Okay, I'm going to write it as vcx in the I plus vcy in the j. Two things I don't know. All right, equals. Let's see. I'm looking at this one right here. Yeah, I'm looking at this one. I'm going to do the cross product, so that'd be 0.5 omega dc. K cross J is a negative I plus 0. Yeah, so that's it. So velocity of c is equal to this. Let's solve it. So the j's on the left-hand side, I have velocity of cy equals j's on the right, none. Okay, so the velocity of c vertically is 0. Well, maybe you expected that, because if you think about it, or if you look at it, you see it's on a circle. right? The motion of C is on a circle. Well, then it can't be going up and down. It's up as high as it's going to go. So it has zero velocity. Maybe you knew that, maybe not. But anyway, the equation tells you that. Okay, for the left-hand side, how many x's? I have VCX. That's the only one I got. How many you got over here? I've got minus 0.5 omega dc. Okay, there we go. Now let's get the second equation. This one right here. And let's punch numbers in and see where we go with that one. Okay, so VC. Okay, well that is a minus 0.5 omega dc. That's VCX. That'll be in the I. Plus, what's the velocity of C in the Y? 0, J. Okay, so that's the velocity of C. And that equals, let's do this cross product. It'll be 3 times D. D is 0.75, so that looks like that is 2.25. 2.25. Let's see, sine of 60. I minus cosine 60. J. Oops. J. Plus little v sine 60 I minus cosine 60 J. Alright, so let's pull off the i's and the j's. So over here I've got a minus 0.5 omega dc equals, okay, over here on the right I have 2.25 sine of 60. I have another one plus v sine 60. Okay, on the left, how many j's? I got none. On the right, I have a minus 2.25 cosine of 60 and a negative v cosine of 60. Okay, so if you want to solve this guy, all right, then just divide this guy by the cosine of 60, and you'll find that v, little v, is equal to a negative 2.25. Okay, so that means that this collar C is actually coming in. Not sure that I guess I believe that. Anyway, if I haven't made a mistake, it's coming in. And now that I have v, I can put it into this other equation and then solve for omega dc. So minus 0.5 omega dc equals 2.25 sine of 60. I don't have a calculator, I punch that in, plus v, okay, plus v is a negative 2.25, unless I made a mistake, it's negative 2.25, times the sine of 60. Alright, so you just grind that out, and omega dc is, whatever it comes up to on your calculator. Alright, so that's the velocity part. Now they also want the acceleration, so what do? I mimic the velocities. So I'll put those in blue over here on the left. So the first equation, I'm just going to mimic this guy right here. The acceleration of C equals the acceleration of D. Got to remember that those are vectors, right? Just so I don't screw something up. Plus alpha of DC cross R from D to C minus omega DC squared R D to C plus 2 omega cross V rel, and between D and C there is no V rel, plus an A rel, so those are gone as well between D and C. So I mimicked that equation. The next one I'm going to mimic is this one right here. So the acceleration of C is equal to the acceleration of A plus this is going to be alpha of AB cross R. It's going to be the same R as it was before. So it's going to go from A to C minus omega squared AB R A to C plus 2 omega of AB cross VREL. Okay, so the VREL I have right over here. Go ahead and put that in there. Cross V sine of 60 I minus cosine of 60 J plus AREL. And the AREL you get by pretending to stand on the pipe, and I think that maybe it is accelerating out this way. I'm just going to call it little a. So it'll be little a, but it's along the pipe, which will be sine of 60 I minus cosine 60 J. Okay, so let's talk about this. Acceleration of D. Well, D is in permanent contact with the ground. That's gone. That's 0. What's alpha DC? Oh, I don't know, but it will be, call it alpha DC K. I think it's counterclockwise. Okay, the R is what I had before, so it's right here. And we'll plug that in. Omega DC, I solved for that. That's down here. That's why you do the velocities first, so you can get the omegas. So I know the omega. The R, I'm just going to, it's 0.5J, just like it was before. So I can plug everything in there. The only thing that's not known here is acceleration of C. I've got 2 of them. I've got the X and the acceleration of C and the Y. I don't know what those 2 are. And I don't know alpha of DC. So far I've got 3 unknowns. Now let's look at the next guy. Okay, the acceleration of A. Oh, that's 0. Why? Permanent contact with the ground. Alpha AB, I know that. That is 5K. So this guy right here is 5K. The RAC, I already got that. It's this guy right here. So if you're careful and neat, you can just copy that back over here so you know the R. The D I know. Okay, the omega AB, that's given. That's equal to 3, so I can plug in there. The V, what am I going to plug in for little v? I've got it right here. So what I'm going to do is I'm going to put in right here, let me change the color. What I'm going to plug in right there is a minus 2.25. Unless I made a mistake, that's what that'll be. So I plug in a negative 2.25 right there. Omega AB, I've got that. That was given. And now the thing that's unknown in this equation is this guy right here, this little a. So the other unknown is a. So now I've got 4 unknowns in this 2 equations, or 2 vector equations. And so what am I going to do? I'm going to say, well, I'm going to take the top equation just like I did before. I'm going to say that's ACX, ACY, and then I'm going to pull off the i's equal to the i's, the j's equal to the j's. I'm going to do the same thing for the second equation. I'm going to get an I equal I, j equal j, another I equal I, another j equal j. So I'm going to have 4 equations. I'm going to have 4 unknowns. I solve for all 4 values. Is it time consuming? You bet it is. It takes a long time to do these problems. Okay. Is it odd, unusual? Probably not. And once you kind of get used to it, they're all pretty much the same. But that's it. So that's that particular one.